Hello and welcome back. Previously, we had a brief introduction to programming with C Sharp in Unity. And now we are going to start the actual programming. We will make the player move according to input from keyboard. Before going to the script, let's add ground below the player. Select the ground sprite from the sprites folder. Before adding it into the scene, we need to slice it. First, change the sprite mode to multiple and click Apply. Then open the sprite editor. Click on Slice and change the type to Grid by Cell Size. Change the pixel size to 256 x 256 and hit Slice. The image should be divided into 9 squares. This time we don't need to rename these slices. When you're done, click Apply and close the sprite editor. Now open the ground sprite by clicking the small triangle next to its name. Click and drag the big chunk of ground that has grass on top to the scene. Make sure that the 2D view is on. Choose the rectangle tool if it isn't activated. You can move the ground around by left-clicking and dragging anywhere inside of the square borders. Next, duplicate the game object by pressing Ctrl+D or by right-clicking the name on hierarchy and choosing Duplicate. Move the duplicated ground next to the original one. To snap them together accurately, hold down V from the keyboard and left-click near to the corner and drag the game object close to the other one so that it snaps to the opposing corner. Duplicate few pieces more so that the player has room for walking. When you are done, create new empty game object by right-clicking in hierarchy and choosing Create Empty. Reset the position of the empty game object and rename it to Grounds. In the hierarchy, click the lowest ground piece and then hold down left shift and click the topmost piece. Then drag all the pieces on top of the empty game object so that they become its child objects. One more thing before we get our hands on coding is that we add a collider to the empty game object. This way the player doesn't fall through the ground. Make sure you have selected the empty game object that is the parent of the ground pieces and add Box Collider 2D component to it. We need to move the collider to right place. Change size and offset so that it covers the ground completely. You might get different values for size and offset than I, but it doesn't matter. The important thing is that the collider covers the whole ground area. Alright, let's get coding now. Open the player script. First, let's write few variables. Write public float speed and set the default value to 3. Remember the F to specify the value as a float and a semicolon after the statement. Now we have a public float variable that can be accessed from other scripts or from the Unity inspector. Let's create the second variable. Write private rigid body 2D RB. You could set the variable to public and manually set the value in inspector, but we can just find it in the start function. Inside of the curly brackets of the start function, write RB equals to getComponent rigid body 2D and empty parentheses and after those semicolon. Remember to write all the semicolons, parentheses, and other symbols in the right place. If there is even one missing or one extra, the code will result in errors. Also, the letters need to be exactly correct. This line of code finds the rigid body 2D component that is in the same game object as the script. Next, we need to somehow detect keyboard button presses. We would normally do that in the update function, since it is called for every frame. But since we also manipulate rigid body physics, we will be using fixed update instead. Fixed update is called for every physics update, and that could mean from 0 times in a frame to multiple times in a frame. It tries to maintain the updates in constant intervals, so use fixed update if you are dealing with physics calculations. Let's start writing the code. We will be controlling the movement with A and D keys. A will move the player left and D to right. First, in fixed update, let's write one variable. Float y speed equals to rb.velocity.y and semicolon. This will save us some time and space when writing the moving code in future. Notice that we can only use this variable in the fixed update because we defined it inside of that function. Next, under the float, write if parentheses and inside of them input.getKey, then another parenthesis, and inside of those keycode.a. Remember the curly brackets after the if statement. Then inside of the brackets, write rb.velocity equals new vector 2 and parentheses. Inside of the parentheses, we need two values, one for x and one for y, separated by comma. Write minus speed, comma, then the y speed variable we created, and then semicolon at the end of the line. The reason we write minus speed is that when moving to the left, the x-axis value will decrease, whereas moving to the right, it will increase. For the y value, we just set the current value because we don't want to modify it. And then let's do the same for moving right. This time, write else if, parentheses, and inside of them input.getKey. Then another parenthesis, and inside of those keycode.d and curly brackets. Inside of the brackets, write rb.velocity equals to new vector 2 and parentheses, and inside of them speed, comma, y speed. Save the script by pressing Ctrl+S or going to File, Save Script, and return to Unity. Before testing, let's select Player. And from the rigid body, press the triangle next to Constraints and activate Freeze Rotation Z. This will prevent the player from falling to its face. Start the play mode and test. Great work! The player is moving. There are a few things left to do. As we can see, when we stop pressing the buttons, the player slides for a short time before stopping, and it doesn't turn when we move to the left. Let's fix the sliding first. Open the script. We need to check if we are not pressing A or D. And in that case, stop the player. So under the if statements, write else if, input.getKey, parenthesis, keycode.a, and then two of the ampersands, and finally exclamation mark, input dot get key parenthesis keycode dot d. The exclamation mark before the condition turns it into false, which means we are not checking if we press the key, but rather if we are not pressing the key. Also, the two ampersands represent the word and in C#. So, all of this means we are checking if we are not pressing A and not pressing D. Then let's write RB dot velocity equals to vector 2 dot 0 inside of the curly brackets. This means we set the velocity to 0 on both x and y axis. Let's save the script and test. Wonderful, it works as it should. Only thing left is to somehow turn the player according to moving direction. As usual, there are few ways to do this, but we only take a look at one. Select the player game object. In the sprite renderer component, there is a flip function. It has three options, either flip on X or Y or both. In our case, we only need the X-axis flip. Click on the X. Exactly what we are looking for. Deactivate the X flip. Now we need to figure out how to do this in code. Let's open the script. We already know how to influence the rigid body component. So let's create a variable that will store the sprite renderer component. Under the rigid body variable, write private sprite renderer and give it a name, for example, srend, and then semicolon. Notice the uppercase letters. And now in start function, write srend equals to get component sprite renderer, then parentheses and semicolon. Now the script will store the component at the start of the game. Next, we need to change the flipX boolean when we move to left or right. So go to fixed update, and there, inside of the curly brackets of the first if statement, write srend dot flipX equals to true and semicolon. Now when we move to the left, this line of code will flip the player correctly. We also need to return the player back to its original orientation when we move to the right. So go to the next if statement, which moves the player right, and write srend dot flipX equals to false and semicolon. Let's save the script and try it out. Perfect, it's working. Great job! Now we have the player moving and turning according to input from keyboard. In the next episode, we will add idle and walking animations to the player. Remember to save the scene. See you again.